Okay, I had a question about needing some help on page 416, number 19, so I have a problem similar to that to do for you. The question gives you an equation of a parabola, asks you to find vertex, focus, directrix, axis of symmetry. So the first thing to do, looking at the equation, compare it to the two general equations we've been studying about parabola. And can you tell which one this looks similar to? That will be helpful in helping us identify all of the parts of the equation. But we need to get it to look like one of these. Do you know? Well, the y squared is a clue. Which one has the y squared? That's the y. Oh, this one has the quantity y squared. So that's the one we're looking for. So I need to get this equation to look like that. Well, that means that I need to get this to be factored. In fact, it's a perfect square binomial. So what do I do there? Does that factor? Well, 2 times 2 doesn't add up to the middle, does it? Well, that means we can rewrite the equation. So let's rewrite it. How about this? 12x minus 4 equals y squared plus 8y plus a space. We're going to find a new number to put there. The 4 didn't work out, so I moved it to the other side of the equation by subtracting 4. Now I'm going to figure out what would be the perfect number to go there. Remember how to do that? Complete the square. You take the 8, divide it by 2, you get 4, and square that. 16 would be the perfect number to put there. But I can't just go adding 16 to an equation. So if I add 16 to this side, I'm going to have to add 16 to this side. Now I can add that 16. This side becomes 12x plus 12. This side, now that I found that 16, this side factors. 2y plus 4 squared. Now we're getting to look more like the parabola general equation that we have. Technical difficulties on this side, though. Coefficient of x has to be 1. How can I get rid of that 12? Factor. How about this? Now, I'm still not quite there. I don't want that 12 to be there. I need something over here, which is called the a. Oh, you know, on these general equations, I forgot something. A equals 1 over 4c. That's true for both of these. A equals 1 over 4c. So let's have that piece of information there too. Okay, how about if I divide both sides by 12? So I could say x plus 1 equals 1/12 y plus 4 squared. Now we're getting somewhere. Now this equation looks just like that one. When that happens, I can identify all the parts. What is the a? Well, a, this number here, 1/12, it's 1/12, but it's also 1 over 4c. So I could solve this for c, right? 4c equals 12, c equals 3. So I have the value c equals 3. I also need to find h and k, because those are other values that are used in these equations. How do I know what the h is in this general equation that I have here? Well, y minus k, x minus h. So if this is x minus h, then the h has to be minus 1, because x minus a minus 1 equals 1/12, y minus a negative 4 squared. Now I have this in the perfect form to match that one. So h is minus 1. What do you think k is? Minus 4. We know c is 3, right? What's a? A is 1 over 4c, right? 1 over 4c, and we found c is 12, so 1 over 12. All right, so everything seems to work, 1 over 12, and I had that when I divided it to begin with, but it's nice to figure it out again and make sure you have get the exact right numbers. Now, since I have all of these parts, I can just use my equation information to find the vertex, HK, -1, -4, focus, H plus C, H plus C, that would be 2, and what is, focus was what? H plus C, K. What's K? -4. Alright, so I got my vertex, I got my focus. What about my directrix? That's an equation. X equals H minus C. So -1 minus 3. How about -4? Alright, and how about my axis of symmetry? Here, let's put the directrix up here. So we said that was X equals 4, right? And the axis of symmetry, Y equals K. So Y equals -4. And there's all the parts for that equation. So the tricky part is taking the equation that you start with and try and figure out which one of these patterns is it going to fall. I look for the squared term. If the Y is squared, it's this one. The X is squared, it's this one.